Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating application of complexity physics to the seemingly simple game of chess. It's a real game changer, pun intended.
Ooh, I'm intrigued. How are physicists getting involved in chess analysis? I always thought it was purely a domain for computer scientists and AI experts.
That's what everyone thought, right? But Mark Barthélemy, a physicist, has published a groundbreaking paper looking at chess as a complex system. He's not just analyzing algorithms, he's looking at the strategic depth and psychological complexity of the game itself. He's using statistical physics, the stuff that usually deals with phase transitions in materials, to understand the dynamics of a chess match.
Whoa! So instead of just looking at the moves, he's looking at the interactions between the pieces? Like a network?
Exactly. He represents a chess match as a network, where each piece is a node, and the interactions, attacks and defenses, are the edges. He's measuring things like betweenness centrality to identify the most important pieces, the ones that are crucial to the flow of the game. Think of it as finding the key players in a complex network of strategic interactions.
I see. And what about the tipping points? What does that mean in this context?
Right, so he's identified fragility scores, how easily you can remove those key pieces. High fragility means a precarious position. A tipping point, where a small mistake can drastically change the game's outcome. It's like a phase transition, a sudden shift in the system's state. He analyzed over 20,000 top-level matches and found that these fragility scores peak around the middle game, 8 moves before a critical moment, and remain high for about 15 moves after. Amazing, right?
That's incredible. So it's not just about individual brilliance, it's about the overall system's fragility?
Precisely. And even more surprisingly, he found a universal pattern. The average fragility score is the same for all players and all openings. It suggests there's an underlying structure to how chess games unfold, regardless of the player's styles or initial strategies.
That's unexpected. I would have thought player skill would have a much bigger impact. Doesn't this somewhat downplay the role of individual genius in chess?
That's a great point. While the average fragility is universal, the timing and magnitude of these tipping points certainly vary. The study doesn't diminish individual skill. It reveals a deeper, underlying structure that governs the game's dynamics. Think of it as a framework within which individual brilliance operates. It's a fascinating interplay.
So what are the implications of this research? Beyond just understanding chess better, I mean.
Well, it opens up new avenues for AI development. For one, understanding these tipping points could lead to better AI algorithms that can anticipate critical moments and make more strategic decisions. It also has implications for other complex systems, like social networks or even financial markets. The ability to identify and predict these fragile points could be incredibly valuable in many fields.
This is truly mind-blowing. Thanks for breaking this down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Join us tomorrow for more fascinating insights into the world of technology and science. Goodbye, everyone.
Bye-bye.